Okay, hi, welcome everyone. We're excited to have so many new contributors joining us today. This is the Tuesday, October 1st Working Group Component Standard Meeting. Happy fall for those of you who are in an autumn climate right now. I know I'm excited about it. I just moved to Seattle, haven't had seasons in a few years, so I'm very happy about that. So today's session is going to be focused on kind of talking about this mentorship program that we're spinning up and doing a little bit of new contributor onboarding. So the first thing I'd like to talk about, let me share my screen, is how we're thinking about mentorship and what some of the guidelines and expectations for that should be. So I just sent an email out that contained a few different documents. One is these mentorship guidelines. One is the sign-up sheet for mentorship. And then linked out of those is also some guidelines on migrating flags to config, which hopefully we'll get time to talk about. And that email went out to the working group mailing list and also Kubernetes dev. So everyone should have access to those documents if you're members of either of those groups. So this is the first one. Let me zoom in so everyone can see. So this document kind of outlines how we think about our role both as chairs and as mentors in the working group, and sort of what you can expect from the mentorship program. So first off, at a very high level as chairs, what we do is super simple. We kind of define the goals and values for the working group and like what we work on. And then we also moderate discussions through this meeting on the mailing lists, on GitHub, and try to ratify decisions in the working group. And that's kind of it. Most of the technical work is actually done by the contributors in the working group who, with some high-level technical guidance from ourselves as chairs. And sometimes we jump in with code, but our primary job is to facilitate progress on the working group's projects, unblock people, help them move their ideas forward. So as mentors, it kind of continues that, but with a little bit of a higher, more personal commitment, because we're bringing in new contributors, trying to help them ramp up and grow in the community. So the number one goal of the mentorship program is to help contributors grow in the community. And basically that just means we'll help you find important work and help you advance on the community ladder. So, gaining more influence, becoming a reviewer, maybe eventually becoming an approver, or even a sub-project owner over time. The second one is that we can help you navigate the community. Depending on what you choose to work on, you're going to have to interact with many different community members. You're going to have to find who has influence in various areas. You're going to need to build some consensus around your ideas to drive your work forward. And we'll help connect you to those people, help you think about how to communicate with them and how to present your ideas in the best possible way. And then finally, we can provide technical guidance. Sorry? Okay, and then finally, we can provide technical guidance to contributors. So that means two things. First of all, we can help you shape your ideas and refine your designs. That can happen through formal processes like the KEP process, but it can also happen through Slack chat, informal design doc reviews, kind of whatever works best for you to help you think through your ideas and designs. And then we'll also help you by providing code review, help you find key reviewers as well where we don't have development technical expertise. So for a lot of people coming into the community fresh, it can seem like this giant black box, how do I even find the right person to talk to? How do I navigate it? And that's what we're here to help with. And I think very importantly, our role as mentors is to support you in doing the work that you want to commit to. So, we're not necessarily going to tell you exactly what to do. We're not necessarily, going to just give you a list of tasks. A lot of this is about, you taking sort of a higher level scope of like this broad thing needs to be done and then figuring out how to do it with our support, because that's what helps you grow. So that's kind of how we think about the mentorship program. Then I want to talk about our mentorship signups sheet. So we're really excited with how many people responded to our request for help. This is really cool, but it is a lot of people, and we want to manage that appropriately. So in order to make sure that we're not stretching ourselves too thin, to make sure that we're not like over allocating too many people to the same sub-project, we've started this mentorship sign-up sheet that I'll go over to in a second. And this is where you can go to sign up if you want to be mentored for a specific task in an existing sub-project. Maybe you have a new idea for the working group, something that could be standardized, but it's in scope for the working group, but it's not an active sub-project. So basically it's not listed in the mentorship sign-up sheet already, but you want to work on it. There's a section you can put your name down for that. And finally, if you want to be a mentor and you have significant experience in Kubernetes, and maybe you've had an idea for a sub-project that could be in a working group that you wanted to get done for a while, but you don't have time to do it yourself, but you could help someone else do it, you can sign up to be a mentor. So let's go over to that mentorship sign-up sheet in a minute. Does anyone have any questions on this? Sound good? Okay. So this is the sign-up sheet here. And so basically the way this works is that if there's an area you're interested in, just write in your name, your GitHub username, and your Slack handle so that we can be in touch. So for example, there are a few active subprojects. One of the major ones is like the component config flag to config migrations. So we have different numbers of slots available depending on the component and how significant the work is for that subproject. There's also legacy flag prototyping. The only two components we're going to prototype for are kubelet and kubeproxy right now because it's just a prototype. There's no guarantee that it will actually be adopted by the project, so we don't want people to like do that for a bunch of components and then, sorry, it didn't get put in. We just want a few examples so we can think about it in a little more depth. So that's what that subproject's about. And then we have a few open areas in component config ergonomics. So one is somebody needs to write a proposal to solve what we call the instance-specific config problem. And that's basically like there are some config fields that need to be set to a unique value for like every possible instance of the thing that would consume that config. And so because of that, they can't be in a shared object, and we need a way to handle that. So there's more detail on that linked issue. Then there's some work to enable the new strict decoders across components. So that's something that Lee, StealthyBots, and also Alex, who handles Obitech, have been working on. And there's another open slot for another mentee there. And then finally, there's some work that was scoped to increase test coverage for the component config pattern, but was never finished. And so that's also a great area for someone to step in. The next section, again, is if you have a new project you'd like to work on that would be in scope for the working group, but not an active project. It doesn't necessarily have to be a new idea that you've come up with. If you go and look at the KEP that's linked from the working group README page, you can find many things that we have not yet worked on. So great examples of that would be some of the common observability endpoints that should be available across components like /metrics, /config-z, /health-z, making it easier for people to expose those. And some people have reached out to us wanting to work on various pieces like that. So if that's your speed, this is the place for you to sign up for that kind of thing. And then finally, at the bottom, if you'd like to be a mentor and you think you have the experience to do that, please sign up here, write a short bio about yourself, and then we'll reach out and discuss the kind of mentorship expectations and position with you and decide if it's a good fit. Does anyone have any questions on the sign-up sheet?
Hey, hi, am I audible?
Hello.
Hi, this is Lala here. So you mentioned there are certain slots per project. So is it mentioned in the slot? Because then if you have 1 or 2 slots, then 4 people sign up, how that is going to be resolved?
Yeah, so each cell is just for one person. So you'll see here, like it says contributor 1 and 2, and then where they're both open, we have 2 slots. Where one's like blocked out, there's only 1 slot, for example. And then some of them only have 1, yeah. And that's just, again, to manage our bandwidth. Unfortunately, we don't have infinite bandwidth. So please sign up. Are there any more questions? Okay, so once folks have signed up, feel free to reach out to us directly and say, hey, I signed up for this thing. I want to get started. And we'll also make an effort to reach out to everyone who has signed up by the end of the week and help you kind of find a first thing to do. With the flag to config migrations, most likely the first task, if there's two of you signed up for a component, meet each other, either on Slack or email or whatever. And then the first thing to do will actually be to audit that component and figure out what needs to migrate and kind of get a list of things to do together. And we can help with that. And then once you've done that, you can move on. So I'm going to switch over to kind of tutorial mode here to go through the how to migrate flags guide. Don't be intimidated by this guide. It looks like there's a lot of steps with a lot of edge cases. There are some edge cases. At a high level, what you're trying to do is simple. The complexity just comes from the overall complexity of the components. But once you kind of understand at a high level, everything else sort of falls out of that. So I don't want people to be intimidated by the length of these instructions. And I'm actually going to skip the general instructions and go straight to the Kubelet code planners and just kind of do like a code tour so people can get a sense for how it works. So at a high level, again, what you're trying to do is there are a bunch of flags exposed on a component. And we have invented these new configuration structures that can be represented in a YAML file for configuring the component. And we want to use YAML files instead of flags for various reasons. There's a document linked at the top of this document called version component configuration files that explains some of those reasons. If we have time, I can get into that too, but I want to make sure we get through the code tour. So what you basically do is you find where the flags are registered, and you find where the config types are, and then you make sure the correct value is replicated in the config type, and then you kind of update everything else that falls out of moving that field's location from flags over to the config. And so that can be making sure like the new defaults are set correctly, maybe for backwards compatibility or maybe for security improvements, making sure that validation code is correct now that you've moved it, updating the flag registrations so that the values from flags make it into the config for backwards compatibility reasons, making sure you've generated some of the generated code, updating usages in the component, kind of all the things that fall out. But the basic operation is just I'm moving this flag to a config. So I'm going to go into Kubelet and show kind of where some of that stuff happens. So everyone can see. Let's see now. Close this down. There's these.
Just as a preface, if you do not have the Kubernetes codebase cloned, if you don't have an environment set up and you've never built Kubernetes before, don't be intimidated. It's not super difficult to get started. We have a developer guide, and if you want some help running through that, I'd be happy to take some time and help you. Just reach out to me, Stealthybox, on probably a Slack direct message. So.
Let's see. So this is the tour of the kubelet. Not all components are structured exactly the same way. You'll see there's also a kubeproxy section in that guide where it has a little bit of a different structure, but the high-level ideas are still the same. So in kubelet, all of the flags that have not been migrated to config just about, there are a few exceptions, but just about all of them are represented in this kubelet flags struct, which is in the options package under command kubelet. So you can see these are all here. Now, if I was going to migrate a flag to config, the first thing I would do would be to copy, for example, one of the fields out of here, and then put it into the config types. So the config types live in two places for most components. There's both an internal type and an external type that you can see here. The way that Kubernetes API machinery works is the external types have the versions on them, and the internal type is kind of a hub for converting between different versions of the config API. And so when you move a field from a flag into a config, you have to make sure it's represented in both places. The way it works is the config file, which has the external type, is read in, then it's converted to the internal type, and that's what's validated and used in the runtime. So first we can look at the external type, which is in the staging subdirectory because we publish it out for consumption. So if people want to write tools to work with our configs, they don't have to clone the whole Kubernetes project. So the external types are here. Staging source, k8s.io, kubelet config v1 beta 1, types.go. So again, this is just another struct. If I was moving a flag to config, I would just copy the value out of here and paste it somewhere in here as the first step. And I would then do the same thing for the internal type, which is in package kubelet APIs config types.go. You'll notice that the format of this struct is basically the same as the external one, and that's because it has to be able to represent everything that every external type can. So they'll basically look the same, and you just have to make sure that the same fields are represented in each. A few notes about the external type that are important. In the kubelet, we kind of have a convention for documenting things about each config field. So there'll be a brief description of what the field does. There's often, because kubelet also has this dynamic config feature, some guidance for how to use dynamic config with the field. That can get tricky, and we can help you with that part. Finally, like some information about the default value. And then this plus optional is important. That has to do with some of the parsing, and we pretty much have it on every field in the config. Also helps with backwards compatibility. And then finally, these struct tags are important to get right. They contain the name of the field in JSON. The reason we do this is because in Go you have to have a capital first letter so that the field is public in Go, but in our YAML and JSON documents, the convention has always been to start with a lowercase first letter. So this is how Kubernetes deals with that problem. And then finally, emit empty, which means that if a configuration is serialized out, fields that have the default or empty value will just be omitted. So that's, again, the first step would be to just move one of these fields over and paste it into one of these structures. So then once you've done that, the next thing that you would want to do is make sure the defaults are set correctly. So the defaults live next to the external type. And, so this is where it gets a little bit complicated. So it used to be the defaults lived right next to the external type. A while back, all the external types were moved into staging so that they could be published out for easy consumption by tools. So the defaults are still where they used to be because they don't need to be published out. So the defaults are close to the internal type, but in a version directory. So you'll see there's just a function in here, set defaults kubelet configuration. Kubeproxy is very similar. It has a set defaults kubeproxy configuration. And this just reads through an incoming structure, checks for nil or default values on it, and then, or nil or zero values. And then if those are not the correct defaults, applies the correct default. Okay, so once you've made sure that the correct default is represented in the default encode, then you move on to possibly adding validation or moving validation that was done on flags into the validation function. And so validation is run on the internal structure. So once a structure has been read in and defaulted, it's then converted to the internal. So we only have one set of validation code we need to write, and that checks that everything is shipshape before we move on to starting the kubelet runtime with that configuration. So you'll want to make sure that you've added any necessary validation. One of the nice things about moving from a flag to a config API is that somebody actually has to do this operation of removing their flag from their command line they've set and then writing the config file. And what that means is we can actually add validation when we migrate a field for just the config side without breaking users in the process. So that can be a nice thing to be able to do. Okay.
I actually never thought about that before. It lets you, because you have a separate interface, you can do different defaults.
Right.
And
you do right. You can do different defaults, and you can do different validation. You have to be careful with it because things, especially in the kubelet. So in kubeproxy, it's a little different. They have stronger rules around not mixing flags and config, but in kubelet, because the two get mixed, you sometimes have to be more careful. That's just different design decisions that haven't necessarily been reconciled in the overall discussion yet.
And legacy flags supports both patterns, and we don't currently assert an opinion as a working group as to what components should do for flag overrides at the moment.
Right, that's right.
Just as a little background.
There are some arguments that have spun up again recently around that, and so we may decide ultimately that they shouldn't be merged. That's an important discussion for us to standardize on ultimately. But it should not block migrations of flags into config because it's possible to do it either way. And so what we'd recommend is that people just stick with whatever the existing convention is in the component that they're working on. And then once we've got all the flags into config, we're using the config API. That's sort of a simpler place to be to figure out the other discussions. So then finally, what you would do once you've kind of made sure everything looks right is go move back in the options file the flag registration to target the config. So let me zoom out just a little bit. So there are two flag registration functions for kubelet. One registers flags for the kubelet flag struct, which again are things that haven't been migrated. So you can see that here. And then just after it, there's one that registers flags against those configuration structs. And so this is how we maintain backwards compatibility in the kubelet with the existing command line. Once you move a flag in, once you move a registration from here just for flags, so you basically would just cut and paste it from here to here, and then update it to target the config structure. Once you move it, it will automatically be march deprecated. And so our goal is to deprecate all flags in favor of a config. For the most part, there will still be a few flags like the one that tells you where the config file is that we never move and never deprecate. But overall, the goal is to get to a API for each component that is actually versioned the same way standard Kubernetes APIs are. And that makes it much easier to avoid breaking users by changing the command line. Finally, there's a step where we run code generation. So you'll see in the config directories, there's, for example, these zz_generated.deepcopy files. These are built by that make generated files step. And they just generate a bunch of convenience methods for working with configs, like deep copies, for example. You'll also see generated conversions in various places between the external and internal types. And so it's very important to run that or things won't work. And finally, once you've updated it, you have to go through and update all the places it's used in Kubernetes. The most obvious one is in the component itself, but there are actually a few other things in the Kubernetes core repo that depend on these config types. One of them is kubeadm. So often it needs to be updated when a flag is migrated. And another one that's easy to overlook, but will cause pre-submit tests to fail if you don't update it, is kubemark, which does the performance tests of Kubernetes. Typically, you'll need to edit the kubemark hollow kubelet.go file, which is where they construct their config for the tests. And then finally, there are some tests that are common to most configs. One is the fuzzers that just sets a bunch of random values and performs round-trip tests to kind of make sure everything is working appropriately. And then some components have additional helpers and tests that you'll have to find and update. Usually those will show up as test failures or compilation errors. And then we'll also double check in code review that you got everything. So that's just a brief tour of kind of the process of migrating a flag to config. Again, it looks complicated. It looks like there's a lot of steps. It's definitely not trivial, but it's not as hard as it looks. So don't be intimidated by this.
Also, round tripping is just the idea of going from an external API object into the internal type and then back to some external type, or vice versa. So it's a little jargon.
Right, and we run those tests to make sure that there's no data corruption or loss in between. So that's what I planned for today, just to kind of go through that quick tour and overview of the mentorship program. So I guess we can open up for open discussion. We have actually we're at 9 o'clock, unfortunately. All right, so that's it. Thanks everyone for coming.
Yeah.
If you had questions that we couldn't address due to time, please ask in Slack or on the mailing list, and we'll do our best to be available. And we're excited to have all of you helping. So thank you very much.
And yeah, if you signed up, reach out to your buddy. Reach out to the other person who also signed up on the same thing with you, and learn each other's names and time zones and stuff so that you can better collaborate. If you do that, then we can all get to know each other a little and build some community. So yeah.
Awesome. Thanks so much, everyone. Have a great day. Happy fall.
Mm-hmm.
Thank you.
Thank you. Bye-bye.
Bye.
Goodbye. Thanks for joining.